Hello everyone. Okay, so in this video we're going to be discussing mutually exclusive events and the addition rule. So you're probably asking yourself, what's a mutually exclusive event? I am so glad you have asked. So a mutually exclusive event is when two events are said to be mutually exclusive if they cannot happen at the same time. So they can't happen at the same time. So for example, when you flip a coin, you can't get a heads and you can't get a tails, right? So it can't be raining and not raining at the same time. You can't roll a 5 and a 6 at the same time on a dice. So a mutually exclusive events are two events that cannot happen at the same time. So, addition rule. So, these are the addition rules. These are not in your log tables. You need to know them. So, mutually exclusive. So, if I want to find, if two events are mutually exclusive, if I want to find the probability that either event happens, so event A or event B happens, it is probability A plus probability B of the event B. So, remember, in statistics, not statistics, we're doing probability. In probability, or means addition. So when you see the word or, you are thinking of addition, right? Non-mutually exclusive events. So probability A or B, that's going to be equal to probability A plus probability B minus probability A and B. So when two events happen at the same time. So when they both happen. So a non-mutually exclusive event would be something that can happen at the same time. So I can roll a even number and a multiple of 3, right? So for example, if I were to roll a dice, I can get 1, 2, 3, 4, 5, 6. A multiple of 3 is 3 and 6. Then if I want, say, an even number, 2, 4, 6. If you notice here, right, they both have a 6 in common. So I can get a multiple of 3 and an even number. So they are not, so they are non-mutually exclusive events. And that's when we use this formula here. But again, no point me talking. Let's do some examples. So determine if the events are mutually exclusive or non-mutually exclusive. Then determine the probability of each. So we want to find the probability of selecting a boy or a selecting a boy or a blonde person from 12 girls, 5 who have blonde hair, and 15 boys, 6 who have blonde hair. So we want to find the probability of selecting a boy or a person who has blonde hair. So are these mutually exclusive events? They are not mutually exclusive because I have boys who are, I have people who are boy and blonde. So I'm going to use my formula here. Probability A or B. Probability A plus probability B minus probability A and B. So the probability of a boy. So boy or blonde. So probability of a boy. Probability of boy is, so it's 12 girls, 5 are blonde, and 15 boys, 6 have blonde hair. So there are 12 plus 15. There are 27 people in the class. There is a 15 in 27 chance, or 5/9 chance of them being a boy. What's the chance of them being blonde? Well, 5 girls have blonde hair and 6 boys have blonde hair. So 11 people have blonde hair. So it'll be 11 all over 27. And then I want to subtract now the probability that someone is blonde and a boy. The probability they're blonde and a boy. If they're blonde and a boy, how many blonde boys do we have? We have 6. So be minus 6 over 27. Put that in your calculators. You're going to get 10 in 27. So the probability of a boy of selecting someone who's a boy or blonde is 10 in 27. I now find the probability of drawing a king or queen from a standard deck of cards. So we want the probability of drawing a king or a queen. So are these mutually exclusive events? Yes, they are, because I can't draw a king and a queen, right? It's either a king or a queen. It can't be both. Now, if it said king and a diamond, I have a diamond king, right? So then they would be non-mutually exclusive, but these can't happen at the same time. I can't draw a king and a queen. So it's going to be probability A or B. The non-mutually exclusive formula is just probability A plus probability B, which is probability of drawing a king is going to be 1 in 13. Probability of drawing a queen is 1 in 13. So the probability of drawing a king or a queen is 2 in 13. Right, let's look at some more examples here. So determine if the events are mutually exclusive or non-mutually exclusive, and then determine the probability of each. So the probability for a driver license applicant to pass the road test the first time is 5, 6. So now let's write that down. The probability of passing your test the first time is 5, 6. The probability of passing the written test is 9/10. And the probability of passing both. Oh, so this is the first attempt, and the probability of passing both tests the first time, so passing the test and the written, is 4/5. Both the first time. Are these events mutually exclusive? What's the probability of passing the test, either test the first attempt? So probability of passing the driving test the first time, or the written test the first time. These are non-mutually exclusive events, because of course you're going to have people who pass the written and pass the driving test first time. It's me. I passed my driving test and did my written test first time. Just want to drop that there. Right, so probability test or written. So probability of passing the test first time plus the probability of passing the written first time minus the probability of passing both the first time. So probability of test is 5/6. Probability of passing the written is 9/10 minus 4/5. So 5/6 plus 9/10 minus 4/5. That the probability of passing the test or written the first time, picking someone, is 4/15. 4/15. So 14/15. So that does make sense. You have a 14/15 chance to pass either or the first time. Like, that's fair enough, I think. Find the probability of tossing 2 dice and either one showing a 4. So either one shows a 4. So the probability of getting a 4 is 1 in 6. Now, the probability of getting a 4 and a 4 is going to be 1 in 36. Right? Probability of getting a 4 and a 4 is 1 in 36. Could we multiply the two probabilities together? We'll get into that when we get to independent events. So let's look at here. So I want the probability of getting a 4 on the first one or a 4 on the second one. So the probability of getting a 4 on the first dice is 1/6. Probability of getting a 4 on the second dice is 1/6. Minus the probability of getting a 4 and both getting 4 is that. That is going to be equal to 1/6 plus minus 1/36. That's going to be 11/36. So that is the probability of either or showing a 4. Now, another way you could have done this is you could have listed out all your options. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, this would be a bit of an effort, but you can do it. 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. 1, 2, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, 1, 4, 1, 2, 4, 3, 4, 5, 4, no, 4, 4, 4, 4, 5, 4, 6, 4, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. So if I highlighted all the ones where I have a 4, so I could get 1, 4, I can get 2, 4, 3, 4, I can get 4, 4, 5, 4, or 6, 4. But I could also get a 4 and a 1, a 4 and a 2, a 4 and a 3, and a 4 and a 6. And I forgot the 4 and a 5, but okay, you get the points. Right, now can I move these ones over? I didn't set up right because I'm rushing. Five, 6, so 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 7, oh, 6, 6. Right. Then if you were to highlight all of them here, you have, again, like I said, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have 11 possible outcomes there. So probably getting at least 1 4 is 11 out of 36. And that does check in with what I got there. I really hope you can hear my dogs barking because they're going wild and I'm not re-recording this video. Right. Find the probability of selecting an ace or a red card from a deck of cards. So this is non-mutually exclusive because I can have red aces. So the probability of getting an ace is equal to 1 in 13. The probability of getting a red card is equal to a half. And then the probability of getting a red and an ace is 1 in 26. I'll go up and check my little deck of cards up here. The red aces. Look, I can get a ace of hearts, ace of things. So I have 2 options out of 52, which breaks down to 1 in 26. Right, next one. Determine. Oh, sorry, I need to do this now. So, probability of getting an ace or red card. It will be 1 in 13 plus a half minus 1 in 26, which is 14 over 26, which is 7 in 13. Right. Next one. Determine the probability that card is drawn is red or a face card. My face card never declines. My God. Eat it. Eat it. Eat it. Eat it. Eat it. So a face card usually just means king, jack, or queen. So a card that has a face on it. Ace is not counted within that. So king, jack, or jack? Yeah, jack or queen. So red or a face card. So, again, probability face card. I have... Let's go... I really should have brought this photo down. Bing, 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 bing. Right, so, if you notice here, I have my jack, king, queen of clubs, my jack, king, queen of spades, jack, king, queen of hearts, jack, king, queen of diamonds. So, the probability of getting a face card... is going to be equal to 12 over 52, which is going to be equal to 3 over 13, right? And then the probability of getting a red card is a half. So put in here. So the probability of a face card is 3 over 13. The probability of a red card is a half. And the probability of getting a red and a face card is equal to, so we have two sets of, so I could have king, jack, and queen of hearts, and king, jack, and queen of hearts, and king, jack, and queen of spades. So I have 6 possible red face cards. Put that over 52. 6 over 52 gives me 3 over 26. So probability of a face card or red is going to be 3 over 13 plus 1 half minus 3 over 26. 3 over 13 plus 25. It's going to be 16 over 26, which breaks down to 8 over 13. So the probability of getting a face card or a red card is 8 over 13. My probability of 2 dice being tossed and showing a sum of 6 or a sum of 9. So a sum of 6 or a sum of 9. Well, is these mutually exclusive or not? These are not mutually exclusive. Right, these are not mutually exclusive because I can roll 2 dice and you add up to 6 and add to 9. That makes no sense. That literally makes no sense. So I can't be doing that. So let's just kind of draw out my two-way table here to gather my probability. So this is my first dice. 1, 2, 3, 4, 5, 6. My second dice. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 1 plus 1, 2. 1 plus 3. 1 plus 2 is 3. It'll be 4, 5, 6, 7. 2 plus 1, 3, 4, 5, 6, 7, 8. 3 plus 1, 4, 5, 6, 7, 8, 9. This would be 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. So let's highlight now. How many of them sum to 6? So I can't really see that, can you? Let me change it all to black. I'll change it all to black now. Yay, I'm so smart. Right. Right. So 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2, 5 plus 1. So the probability of getting sum to 6 is equal to 1, 2, 3, 4, 5. 5 over 36 possible outcomes. The probability of sum to 9 is going to be 1, 2, 3, 4. I only have 4 possible ways I can add up to 9. So it's going to be 4 over 36, which is 1/9. So now, since these are non-mutually exclusive events, I can just add them. A or B. So the probability of A plus the probability of B, which is going to be equal to probability of A, that was what? 5 over 36? 5 over 36 plus 4 over 36, which is equal to 9 over 36, which is equal to 1/4. So the probability of rolling dice and adding up to 6 or 9 is going to be a quarter. And finally, the last question here. A weather forecast states that the probability of rain is 3/5. The probability of lightning is 2/5. The probability of both is 1/5. What's the probability it's raining or lightning? Are these mutually exclusive? They are. Sorry, brain fart. They are not mutually exclusive. So what do I say up here? No, sorry. These ones are mutually exclusive. I say not. These are mutually exclusive. That's where we use the other formula. These are not mutually exclusive because... And these are not mutually exclusive because it can rain and it can be lightning at the same time. So, it's going to be probability rain or lightning. So, probability rain plus probability lightning minus probability of rain and lightning, which is going to be 3/5 plus 2/5 minus 1/5. And that is going to equal to 4/5. So the probability that's going to rain or be lightning is going to be 4/5. Anyway, this video was a bit of a mess, but I'm not doing it again. Right, so this is a video on mutually exclusive events. So just remember, mutually exclusive events look like Wolverine, right? Anyway, mutually... I entertain myself. Right, mutually exclusive events are events that cannot happen at the same time. That's all you need to remember, right? And then you need to remember this formula, the addition rule. So A or B, if they're mutually exclusive, it's probably A plus probability B. If they're not mutually exclusive, it's probably A plus probability B minus probability of them both happening at the same time. And that's the end of this video. And I hope it helped. And I'll catch you guys later. Bye-bye. Bye.